Good afternoon, everyone. Today, we're diving into some fascinating research from the LaneChain team about a challenge that many of us face when working with AI coding agents. The question is, how do we turn Claude Code into a domain-specific coding agent that actually excels at our custom libraries and frameworks? This research, led by Alian Ishfaq, reveals some surprising insights that could transform how we approach AI-assisted development in enterprise and specialized environments. Let's explore what they discovered and how you can apply these findings to your own projects. The challenge. First, let's establish the problem. We all know that coding agents like Claude Code are incredibly powerful when working with popular libraries. Think React, Python's requests library, or well-documented frameworks like Django. They've been trained on millions of examples of code using these tools. But here's where things get tricky. Point these same agents toward your custom internal API, a newly released version of a framework, or a niche domain-specific library, and suddenly their performance drops dramatically. They start hallucinating methods that don't exist, they miss critical implementation details, and they fail to follow your organization's specific patterns and best practices. This creates a real problem for enterprise teams and anyone working with specialized tools. The very scenarios where we most need AI assistance, navigating unfamiliar or poorly documented systems, are exactly where current agents struggle most. The big discovery. Now, here's where the LaneChain team made their breakthrough discovery, and I have to say it's quite counterintuitive. Their key finding was that high-quality, condensed information, combined with tools to access more details as needed, produced the best results. But here's the surprising part. Simply giving agents raw access to all your documentation didn't improve performance as much as you'd expect. In fact, it often made things worse. The context window would fill up faster with irrelevant information, and agents would get lost in the noise. Instead, what worked best was a carefully curated, concise guide that gave agents the essential knowledge up front, combined with selective access to detailed documentation only when needed. This challenges our intuition that more information equals better performance. Sometimes the right information, presented in the right way, beats comprehensive access to everything. 4 configurations tested. To test their hypothesis, the team created 4 different configurations of Claude Code, each representing a different approach to providing domain-specific knowledge. First, they had Claude Vanilla, basically Claude Code right out of the box with no modifications. This was their baseline. Next, Claude plus MCP. This version was connected to their MCP doc server, giving it tools to access documentation dynamically. Then Claude plus Claude.md. This version had a detailed, handcrafted guide file specifically about LangGraph development patterns and best practices. Finally, the combined approach, Claude with both the structured guide and access to documentation tools. Each configuration was tested on identical tasks to see which approach would produce the best code quality and task completion rates. MCP Doc Tool. Let me quickly explain the MCP tool they built, because this is something you can actually use in your own projects. MCP Doc is an open-source MCP server that exposes 2 simple but powerful tools. The first is List Doc Sources, shares the URLs of available documentation files, and the second is Fetch Docs, which actually retrieves and reads specific documentation content. What's brilliant about this approach is its simplicity and adaptability. You can easily configure it for any library or framework by just pointing it to your documentation URLs. The LaneChain team used it to provide access to both Python and JavaScript documentation for their frameworks, but you could just as easily point it to your internal API docs or any other technical documentation. Claude.md, the secret sauce. Now, let's talk about Claude.md, which turned out to be the real game changer in this research. This wasn't just a dump of documentation content. Instead, it was a carefully crafted guide that included 4 critical elements. First, structure and patterns, the essential project organization, export patterns, and deployment practices that agents need to know from the start. Second, and this is crucial, pitfalls, and anti-patterns. The team documented all the common mistakes they'd seen LLMs make repeatedly, like incorrect interrupt use, wrong state update patterns, and overly complex implementations. Third, specific guidelines for the hardest problems, things like streaming implementation and human-in-the-loop patterns where agents consistently struggled. And finally, smart references. They included documentation URLs at the end of each section, but only for deeper exploration, not as a replacement for the curated guidance. The key insight here is that this file was fundamentally different from raw documentation. It was condensed, opinionated, and focused on the most important information for getting started quickly and avoiding common traps. Comprehensive Evaluation Framework. Now, measuring the success of these different approaches required a sophisticated evaluation framework because simple metrics like does it compile don't capture code quality or adherence to best practices. They created a three-tier evaluation system. Smoke tests verified basic functionality. Does the code compile? Does it expose the right methods? Does it handle expected inputs and outputs? Task requirement tests checked task-specific functionality, proper API integration, correct configuration files, and task-specific unit tests. But here's where it gets really interesting. They used LLM as judge for quality assessment. They had expert developers write reference implementations for each task, and then used Claude Sonnet 4 to evaluate the code generated against detailed rubrics, looking at code quality, design choices, and proper use of framework abstractions. This combination of objective testing and subjective quality assessment gave them a much more complete picture of agent performance. Results. The winner is clear. The results were both clear and surprising. The combined approach, Claude plus MCP plus Claude.md, took first place, as you might expect. Having both structured guidance and documentation access gave the best overall performance. But here's the surprise. Claude plus Claude.md alone came in second, significantly outperforming Claude plus MCP alone, even though the Claude.md file contained only a subset of the information available through the documentation tools. This was a crucial finding because it showed that how you present information to an AI agent is just as important as how much information you give it. A well-structured guide consistently outperformed comprehensive but unstructured access to documentation. Why did Claude.md outperform MCP alone? So why did the structured guide approach work so much better than raw documentation access? The team discovered something fascinating when they analyzed the interaction traces. Claude wasn't actually using the MCP documentation tools as much as they expected. When faced with a complex task requiring information from multiple documentation pages, Claude would typically call the MCP tool once, get some surface-level information, and then stop there, missing the crucial implementation details buried deeper in the docs. In contrast, when Claude had the structured guide, it included carefully chosen pitfalls to avoid and principles to follow. This helped Claude think more systematically and explore different aspects of the library more thoroughly. The real magic happened with the combined approach, where the Claude.md file included strategic reference URLs. This actually encouraged Claude to use the documentation tools more effectively, creating a guided exploration rather than random document retrieval. The lesson here is that AI agents need context and direction, not just access to information. 3 real-world evaluation tasks. To test these configurations, they created 3 realistic, challenging tasks that mirror what developers actually do with LangGraph. The first task was building a text-to-SQL agent, converting natural language to SQL queries, executing them against a database, and returning natural language responses. This required complex database setup and query handling. The second task was a company research agent using web search APIs with structured data collection, parallel execution, and a reflection step to ensure complete information gathering. These weren't toy problems. They were the kind of complex, multi-step tasks that real development teams face when building production systems. Key takeaways for implementation. Based on their extensive testing, the team identified 4 critical takeaways that you can apply immediately. First, avoid context overload. Dumping large documentation files into the context window
doesn't help, it hurts. The naive approach of just throwing everything at the agent leads to poor performance and higher costs. If you need documentation access, build smart retrieval that pulls only relevant snippets. Second, Claude.md has the highest payoff. It's easier to set up than complex tooling, significantly cheaper to run, about 2.5 times cheaper than the MCP approach, and often performs better on its own. This makes it an excellent starting point for any customization effort. Third, invest in excellent instructions. Your structured guide should include core concepts, unique functionality patterns, common primitives, and most importantly, all those recurring pitfalls that you've seen developers struggle with. Popular code generation tools use 7,000 to 10,000 token system prompts because detailed instructions really matter. Finally, the combined approach ultimately wins. While Claude.md gives you the most bang for your buck, the strongest results come from pairing structured guidance with smart documentation access. The guide provides orientation and context, while the docs provide depth when needed. Practical implementation steps.
So, how do you actually implement this in your organization? Here's your roadmap. Start with Claude.md. Document your core concepts and patterns, but more importantly, capture all those painful lessons you've learned. Include the debugging steps that always trip people up, the integration patterns that actually work, and references to where people can go deeper. When you're ready to add smart tooling, focus on building targeted documentation retrieval rather than comprehensive access. Test how your agents actually use these tools. You might be surprised by their patterns. Measure and iterate using both functional tests and quality assessment. The LLM as a judge approach works remarkably well for evaluating code quality beyond just does it work. Analyze your failure patterns manually. They'll reveal exactly what guidance you need to add. And always keep cost optimization in mind. The Claude.md approach is remarkably cost-effective, and smart retrieval can dramatically reduce your token usage while improving results. Conclusion: the path forward. Let me leave you with the key insight from this research. The future of domain-specific coding agents lies in smart information architecture, not just more data access. This research shows us that we need to think like technical writers, not just like engineers. We need to curate, structure, and present information in a way that guides AI agents towards success rather than hoping they'll figure it out from raw documentation. Your next steps are straightforward. Start by creating that comprehensive Claude.md file with your framework's essentials. Add smart documentation tools when you need them, but focus on targeted access rather than comprehensive dumps. Measure quality comprehensively, not just functionality. And most importantly, iterate based on actual failure patterns. They'll tell you exactly where your guidance needs improvement. The combination of structured guidance and smart tooling isn't just a technical solution. It's your competitive advantage in the age of AI-assisted development.